Well, hi there, and welcome to GTRI's software-defined networking and VMware NSX web seminar session. My name is Scott Hogg. I'm Chief Technology Officer for GTRI. And with me for this presentation today is Hunter Hansen, Account Executive for the West Region for VMware, specifically focused on NSX technology and their software-defined networking platform. Today, as Chris had mentioned, the session will be recorded. We'll be providing a PDF of the presentation materials at the conclusion of the presentation. And we'll also have a couple of extra information items for you at the end of the session. So stick around for those, and they'll be emailed to you. And then if you have questions during the session, we'll be going through presentation. And if you have questions, you can put them in the Q&A panel or the chat panel, whichever you prefer, and we can try and answer them as we go. Or at the end, we've got a question and answer session as well. So with that, we can go ahead and get started. We'll go over kind of a brief introduction on software-defined networking, just to level set what we're talking about in terms of the technology. We'll talk about the business drivers, use cases, why organizations would want to deploy software-defined networking, or what business benefits you may receive from using a software-defined networking system. We'll talk about some of the operational considerations that enterprises have when they embark on using technologies like this. Hunter will then lead us through a VMware NSX review. We'll talk about, what we can offer together, GTRI and VMware. We'll have a summary and some questions and answer session at the end, just to give you an idea of what we're going to talk about today. So really, I think, there are benefits of network virtualization, of service and software, virtualization. Servers have transformed from, bare metal servers to virtualized operating systems and now software containers. So we've really virtualized applications in that respect over the last couple of decades. Storage systems have evolved where now it's very much about the software and the features that are provided with the software on that storage platform. DevOps isn't just a popular digital age portmanteau where you take two words and stick them together. It's really a movement of de-siloization of IT and making groups come together in an interdisciplinary, multi-faceted, collaborative way to speed up deployment of software and applications and services and derive more business value out of IT infrastructure in a shorter period of time. If you're interested in DevOps, I recommend the Phoenix Project book. If you pick that up, it gives you a story that explains the benefits of that. But networking really over the last 15 years hasn't changed substantially. We still manually configure network devices one at a time. We've basically moved from Telnet to SSH. That's the whole transformation that's occurred in the last decade of networking. So this funny cartoon here that would appeared in Network World magazine. I don't want to invest in the technology, I just like to invest in the hype. Software-defined has become an overused term to the point where many of us are now numb to the meaning of those words. But really, with software-defined networking, what we're talking about is this approach to networking that separates these control plane, forwarding plane, and management plane that have typically been all together in one proprietary network device in the past, and we're breaking these up and using open source software and open source standards to separate these functions. And by doing so, we get this new paradigm, but we get some other benefits of disaggregation of forwarding from control, from management. And this is seen really, in this higher level architecture of software-defined networking, where we have kind of we have a controller. We have a software controller now that is disaggregated from the hardware forwarding. So now the network elements are just basic devices that, or virtual network elements or agents that, with agents that forward packets in the data plane. but there is central control and intelligence. In the past, the control function has been distributed with the network elements, and routers, switches used routing protocols to share reachability information between themselves to build a topology of the networked architecture, and then they would compute from their own perspective what the best path would be to forward packets to particular destinations. And there wasn't any global view or global control. It was distributed control and distributed intelligence. And router A over on the East Coast may not know about different load considerations or utilization or errors or link failures that were taking place on the other coast. And so we had this routing by rumor environment, and then we didn't have any global way to do things. Like, we didn't have a global view of utilization and how utilization affected our forwarding, and how we might have alternate paths that were unused but perfectly legitimate paths for some application traffic. By consolidating this intelligence about control into this controller layer, and then using a southbound API or southbound protocol to distribute forwarding rules to distributed network elements, this is kind of the classic software-defined network architecture. And then we can have controllers. We can have high availability controller architectures where we have controllers sharing intelligence with each other and synchronizing their global view of the environment. But we also then have a upper layer that exposes this influence to applications. And so now virtualized application services can make requests of the network, similar to promise theory if you're used to that. The application can request that the network make a promise to fulfill some obligation on behalf of the application. So the application makes a request. I need a certain amount of bandwidth with a certain traffic profile, and I want to minimize latency and minimize packet loss for this business critical application between these two systems, and the network then determines if that promise can be upheld. And so we have these separations of layers, and now we can be supporting applications better, or we can automate this in other ways now that we've virtualized and deaggregated these functions. And so typical southbound protocols that people think of when they think of software-defined networking are protocols like OpenFlow or other types of protocols like that. Northbound, it's RESTful APIs, Python, Python control, Python automation, or OVSDB is a southbound protocol. So really this is kind of this high-level architecture. So organizations get some benefits from this. They get greater span of control, better ability to dynamically handle traffic based on application demands. They get better intelligence of the network and better ability to orchestrate it. And then also, you're not making changes to 100 network devices all at once. You tell the controller what you want to have happen, and it disseminates that information. So no longer do you have to maintain each network element's configuration by hand. It's really a centralized policy in the controller that then gets its influenced put onto the lower cost network elements. And so we have improved application experience now, where now we've tied the application more closely with the network rather than the network just being built to handle any type of application without regard to or awareness of application requirements. We have simplified IT operations and automation because we just define a policy once and it gets distributed to all the forwarding elements. And we have an opportunity to open up with these open protocols to a set of vendors that that we didn't use before or in different ways than we had in the past. So when we think of the use cases of a software-defined networking system, we can think of a multi-tenant data center, similar to the compartments in a submarine. We create these enclaves, these segments, these virtual domains, and we have separation of tenants inside a multi-tenant environment, or maybe we do this just within an enterprise just from a security perspective, we want to separate certain applications or functions or servers or systems based on data classification, data sensitivity, security compliance, what have you, or different lines of business. Whatever your policies are, we can separate them virtually into virtual, networked instances, and software-defined networking can help create those layers, if you will. Software-defined networking can also, give us more intelligence to the traffic path. So this picture of this fish over here in the upper right, when typical routers compute the best path, they compute the lowest cost path. And that would typically be the path, from the left side to the right side goes through router 3. But there's this alternate green path through router 6 and router 7, which could largely be unused, unutilized, but perfectly valid. So it's like having a 4-lane highway that is unutilized. And so we could then use software-defined networking to steer certain traffic over different pathways based on a global view of what's happening. Hey, the path through router 3 is getting congested. Let's open up lines of communication through the alternate path to help ensure good application performance. And also, in a spine leaf data center architecture, we need to have a policy, and we distribute that policy on many network devices all at once. And we need them to all be in agreement of what that, policy is and how we want the network to be built. We don't want to necessarily do that one device at a time. If we did it one device at a time, that would be prone to human error. We want to take human error out of it. We want to make things automated and fast to deploy, so we use a controller to kind of put the configuration into the network elements. Also, over here on the lower left, in the past, where we've had access control lists or things like that, or firewall policies, it's been an if-then-else top-down policy. It's very rigid, and we don't have the ability to do Boolean matching, and or not this, if that, and this, match on this kind of packet from this source and destination, and make sure it doesn't have malware, and the time of day is, 8 a.m. to 5 p.m. So we have the ability to have a lot more flexibility in the rules and the policies and how we decide what traffic gets forwarded where. We can copy packets, we can send them in alternate directions, we can do different things with them that we probably hadn't thought of a network being capable to do. And software-defined networking really opens up this creativity in networking and gives us this flexibility and automation and ease of use that we didn't have before. So this is some of the use cases of a software-defined networking system. But what we see is that many enterprises haven't merged their IT silos. The network, the security, and the systems teams aren't working effectively together, and these groups may feel threatened by this new software-defined data center environment. And so they each kind of have their own little roles and responsibilities, and by putting network function virtualization, by putting functions into the hypervisor, putting security and switching and networking and load balancing into the hypervisor and the virtualization layer and making it all software-defined threatens some people's roles and responsibilities where historically there's been an Ethernet connector that physically defined the roles and responsibilities. Your group handles everything on that side of this Ethernet interface, my group handles everything on this side of this Ethernet interface, and that physical point in the physical IT architecture defines the roles and responsibilities from a troubleshooting standpoint. But the truth is, networking, security, and server operations skills, knowledge are transferable to a software-defined world. We just need to kind of break down these silos, get groups to follow more of a DevOps model, and they can embrace this. They may not move all, holistically all the way to a software-defined future. They may just take advantage of some of the automation and orchestration capabilities of a software-defined data center initially, and then grow their capability and grow their functional use as their maturity builds and as their groups continue to cooperate. But at GTRI, we like to see organizations that have, brought their teams together and to a more of a DevOps model, and gotten away from using those physical points of demarcation to define responsibilities, and really created those cross-functional teams to take advantage of some of these advanced. Now it's software-defined networking is becoming more mainstream, and it's not as far-fetched as you might think. It is feasible, but I think some of these operational considerations are what's keeping some enterprises from realizing the benefits that a software-defined networking system has. So VMware has been a long time, GTRI partner and a leader in virtualization and software-defined data center. Several years ago, they acquired a company called Nicira for their network virtualization platform. They fully integrated that into their new versions of virtualization software, and now have evolved the NSX product to provide network virtualization, disaster recovery, security, and to create a software-defined environment that an organization can use easily with the hypervisor platform that they're used to. And so I kind of wanted to lay a foundation of a software-defined world and introduce VMware. And to lead us through the rest of the presentation, I'd like to pass control over to Hunter Hansen, who's going to lead us through demonstrating and showing us how VMware NSX can help our organizations along these lines. Hunter?
Absolutely. Thank you, Scott. I appreciate that. That was a great overview. So I want to say good morning to everybody, and just to sort of reintroduce myself. My name is Hunter Hansen, and I am part of VMware's Network and Security Business Unit, focusing on NSX. And folks, what I'd really like to do today is take you through sort of a conceptual high-level overview of some of the features and functionalities of NSX, from network virtualization to disaster recovery, as well as security, and show you how NSX is really enabling our customers in software to be more agile, efficient, as well as secure. So network virtualization was designed to be as non-disruptive as possible. It's a very non-disrupting deployment, right? Network virtualization is going to begin with the infrastructure that you're very, very familiar with, your physical network, servers, and storage. Now, a common misunderstanding that we get with NSX is that NSX is going to require changes to your physical infrastructure. And I want to emphasize that it will require no changes whatsoever as long as your network hardware can forward IP packets. We have customers currently running NSX over Cisco, Dell, Brocade, HP, Juniper. Again, NSX is essentially agnostic when it comes to the physical infrastructure that our customers are using. And obviously on top of your physical infrastructure, this is where your hypervisors reside. And this has sort of been the standard across the industry for the last 10 to 15 years. So as you'll see during my presentation, this is where we're able to distribute network and security services out to the applications. And we do this to create what you can think of sort of as a network hypervisor, which, like a server hypervisor, allows our customers to programmatically create, snapshot, move, delete, and restore virtual machines. We can now do the same thing, but for entire data centers. And this is to deliver flexibility, agility, and security that hasn't been possible before and really isn't possible outside of a software-defined solution. So again, we do this by distributing network services onto the hypervisors. And this is where they can be provisioned with the application workloads, as well as take advantage of application context. And we can do this because these distributed network and security services are going to be operating right at the application's interface to the data center construct. So you can sort of think of the power of distributed services as little pieces of a network are getting distributed to a broad area, but it's going to act essentially like one large network. Waiting for this slide to move. So let's talk what exactly a virtual network is. Well, like we said, a virtual network is a software container that delivers network services that your connected workloads would expect from a network. It's going to provide the same services as your physical infrastructure. We're just going to move those services into software. So with NSX, we provide logical layer 2 switching, logical layer 3 routing, distributed firewalling, which is the security aspect of NSX, as well as load balancing. And what this is going to allow for is the communication of two VMs, for example, that are residing on the same hypervisor to occur without the packet having to transcend the hypervisor and touch the physical infrastructure. Utilizing the routing feature of NSX, we can also have two VMs that could be on different subnets, still residing on the same hypervisor, communicate without those packets, again, having to touch the physical infrastructure. NSX can also do layer 2 over layer 3, which gives our customers the ability to launch any VM anywhere inside their data center or to a different data center geographically and have them be layer 2 adjacent. You know, a lot of our customers take advantage of this for better utilization of their compute resources. One of the major benefits that a lot of our customers are purchasing and enjoying NSX for is disaster recovery. So a quick example of how virtual networks can really dramatically change what many consider to be an already automated process is the utilization of virtual networks. So today, you know, many customers across the industry are using DR solutions like Veeam or VMware's SRM, and a simplified view of this process is going to look something like this. You'll essentially snapshot the virtual machine and its storage. Your storage system replicates the VM and its storage to the recovery site. And then in the case of a DR event, the virtual machine is recovered, you know, and SRM is able to automate the change of the IP address because now that VM is connected to a different physical subnet. And with a different IP address, now you have to reconfigure security rules to match the new IP addresses. It's essentially a very manual and time-consuming process. It can often be complex and increases the chance of human errors occurring. We recently had a customer who experienced a DR event, and when they were spinning up their DR site, due to some human error, their DR site wasn't able to spin up as rapidly as they liked, and it ended up being down for about 2.5 days. This was a SaaS company, so you can only imagine the impact that that had on their business going forward. So if we look at what NSX could have done for this customer, again, there's really no change to the DR software already in place. You're going to snapshot the VM and the storage. Only with utilizing NSX, you're also going to snapshot the virtual network as well as those security policies. So when you replicate the VM and the storage at the recovery site, you've also replicated the virtual networks and security policies that those VMs are expecting to connect to. So in the case of a DR event, when you recover the virtual machines, the virtual network that those VMs are expecting to connect to, again, is already there. And what this means is that there's no change to the IP address and also no need to go through and reconfigure security policies. All of those have already been replicated. And we're finding that this leads to about an 80% reduction in the recovery time objective of our customers today. And again, this is just a very simplified version of how NSX works for disaster recovery, but it's one of the many uses that our customers are enjoying with network virtualization. There we go. So folks, what we're looking at right here is how many of our customers are benefiting from NSX on top of their existing Cisco infrastructure. Across the industry, every data center is experiencing a major increase in east-west traffic flow, VM to VM traffic. And as modern application designs route traffic between workloads on different tiers, you know, for example, an app tier and a database tier, in a traditional network, that traffic must go out across the network. It utilizes the oversubscribed core to get to the core router and back to the VM that may be residing on the same UCS blade in this example. Again, we're just using Cisco as an example. You can replace them with Brocade or Dell. It really doesn't matter for NSX. And essentially, by having to send all this traffic through the physical infrastructure, it forces the industry to invest more into their core, when they would rather actually save to invest in maybe a leaf-spine refresh or a more strategic initiative inside their data center. Well, if you look here, NSX is able to offload that traffic. Leveraging distributed routing in the hypervisor, even routed traffic wouldn't have to leave that hypervisor and touch the core infrastructure. And this alone can greatly extend the life of the existing core infrastructure by reducing the amount of traffic that it has to deal with on a day-to-day basis. And if you look on the right here, even when workloads are on different hypervisors, NSX would only be utilizing the aggregation portion of the network. It still wouldn't need to utilize the core. And folks, this is exactly the same picture, but this is from a security perspective, and by far the largest use case that we're seeing customers deploy NSX. You can see here that in a typical design, we have to essentially hairpin packets out to some kind of physical firewall device. Well, by leveraging micro-segmentation inside of the hypervisors, we're able to essentially give all packets inside of your network a stateful layer 4 inspection before they would move anywhere inside your data center. So let's talk a little bit more about micro-segmentation. So micro-segmentation spawns from really a need in the industry, a need to be much more secure. Essentially, the way that it's been done for a long time is we have a perimeter firewall that controls sort of the north-south traffic, but there's little to no lateral controls inside the perimeter. For those of you that are familiar with the attacks at Home Depot and Sony and Target, this model right here on the left is how their data center was able to be threatened. Essentially, once the threat was able to make it in the case of Target, their HVAC system, a low-priority system, was targeted. And once that threat had made it through their perimeter, they were able to hop around from critical app to critical application and extract that information, which has led to all kinds of issues for Target going forward. Really what the industry's wanted to do for a long time is segment everything out. Right? So micro-segmentation, or sort of a zero-trust approach. However, placing physical firewall devices all throughout the data center just hasn't been feasible from a CapEx and an OpEx perspective. However, by baking a stateful layer 4 firewall into the hypervisor, we can bring micro-segmentation to the industry today in a way that's not only feasible from a CapEx and an OpEx perspective, but from a management perspective as well. So to get a little more granular and show you how that works, essentially what we're doing is changing where firewall rules are going to be enforced. So you can see as the packet transcends the VM, before it touches the physical infrastructure, before it communicates to any other virtual machine, it is already receiving a stateful layer 4 inspection. And from a management perspective, something that a lot of our customers enjoy about NSX is that this firewall policy is essentially attached to that virtual machine. So as that VM migrates across your data center, those security policies are going to follow that virtual machine. And this is without any changes to your physical infrastructure. It's done simply through the automation that NSX is able to provide. And if that VM is ever retired, those security policies are going to be retired with it as well. We had a customer where probably a lot of you buy overpriced coffee that had 8 million stale firewall rules inside of their data center before they actually purchased and deployed NSX. NSX was able to take those 8 million and shrink them down to a manageable number of firewall policies because we can control all these security rules and policies from a centralized management point. Again, something that's available only in a software-defined solution. And just to get a little more granular around the security aspect of NSX, NSX provides native isolation. So virtual networks essentially have a zero-trust policy where they will not be able to communicate without you explicitly allowing those virtual networks to communicate. We also have, of course, our explicit allow communication. And that's going to be the standard stateful firewalling controls, which are going to filter on things like source and destination, addresses, ports and protocol. So this alone can dramatically reduce the risk profile inside of your data center. You know, again, if Target and Home Depot and Sony had been utilizing NSX with micro-segmentation, we would have greatly decreased the attack plane and limited the damage that was done to those companies. And finally, NSX has advanced security controls. You know, we work with a lot of our partners like Palo Alto, Intel Security, Trend Micro, Checkpoint, and that's to deliver their advanced next-generation firewall inspection and IPS. And we do this by essentially allowing them to integrate with the NSX platform and really leverage the distribution and the automation that is delivered by NSX. So with that, again, this is just a very high-level overview of NSX. And with that, Scott, I'm going to go ahead and pass it back to you.
Okay. Thanks, Hunter. One person, Brian Chase, commented, sounds like SS7, signaling system 7 for the internet. How did you know that was the topic of my master's thesis many, many years ago? You know, that centralized control and policy, but distributed on a, large-scale telephony network, in the carrier's world. We also had another question. What level of collaboration with ISPs does this require? Hunter, could you answer that? Is the ISP involved in any VMware NSX configuration?
The ISP. Honestly, Scott, I think I may want to get an engineer on that. That's a little bit more than beyond my capabilities.
Yeah. I don't think that an ISP is involved, even if you're using VMware NSX for the disaster recovery use case and you've extended, the virtualization of these, VXLAN tunnels between data centers. That's all done above layer 3. So you just need layer 3 connectivity between those locations. Your MPLS service provider or your internet service provider is unaware of those tunnel packets that are being sent across data centers. And you can encrypt that traffic, of course, as well. So, yeah, good questions. Keep them coming. If you've got additional questions, we'll go through a Q&A session here in a little bit. So go ahead and put them into the chat window if you have questions. So at GTRI, we have a software-defined networking virtual team. We have advanced professional services, expertise, and we have partners like VMware to help our customers realize the benefits of these software-defined network, software-defined data center, and network virtualization. GTRI has completed our network virtualization VMware specialization, and we're focused on solutions like this on behalf of our customers to help our customers' businesses benefit, and our customers' customers benefit from getting applications faster with newer features, more readily. And so as our customers are, desiloing their organizations, combining their workforces, collaborating, they'll take advantage of network function virtualization and software-defined data center. And VMware is really a near-term, easy-to-use version of software-defined networking because it leverages the hypervisor that's already in your environment. It leverages the configuration expertise with VMware software that your teams are already operationally adept at maintaining and configuring. It just extends it in this way and gives you this extra, these extra policies and lays this foundation for a software-defined future, but it's not like making a giant leap to software-defined data center where all of your network and security engineers are going to be programming in Python. Certainly, VMware NSX has northbound APIs and can go that route, and your DevOps teams can leverage it in those ways, but you don't have to leverage it in those ways. And there's multiple use cases, as Hunter mentioned, for VMware NSX. The micro-segmentation is a useful one. Many organizations have like a VLAN 100, and there's many servers, virtual or physical, in that VLAN 100 that's spread across a couple of their Ethernet switches in their data center. But now they want to start to break that up and create a micro-segment, like I want all my servers with the credit card data on them to be enclaved, separate from the others. But today, to do that, you'd have to install some firewall inline. It would be a choke point, but it'd also be a performance choke point. And then you'd probably have to readdress those systems to a different IP address space that it would add a lot of administrative overhead. But with VMware, with NSX and micro-segmentation, you could simply create an enclave and keep those servers in the same address space, but create a logical separation of them from the other servers on VLAN 100. So what we'd like is, if you've got, questions or interest in VMware NSX, GTRI and VMware can help you embark on your path towards a software-defined future. So we had a question here come in on the chat. how can economies of scale be achieved with micro-segmentation security versus using hardware firewalls and load balancers? Well, I'll go ahead and answer this, Hunter, if you don't mind. With hardware firewalls and load balancers, you're still configuring the devices manually. With a software-defined data center platform like VMware NSX, you're essentially configuring hundreds of firewalls or many firewalls, and you can have them all synchronize and agree on what that common policy is. So you don't have to configure things manually. They're configured logically. But yet, you could still use a virtual firewall platform. Let's say, your security teams are familiar with a certain brand of firewall administrative interface. You can still leverage that virtual stateful firewall in the hypervisor network function virtualization layer. And so your security team is already familiar with that graphical user interface or how policies are created on that virtual firewall. The security team can still have that control, can still have a user interface and an operational model that they're familiar with, but do so in the context of a virtualized network hypervisor. And the same thing for load balancers too. If the load balancer was traditionally maintained by the network engineers, you can get a virtual instance of the same brand of load balancer you use today, let the network team administrate it, but now they're not maintaining a physical device, they're maintaining a virtual device, and those virtual devices can support many of different applications. So you get economies of scale because you can configure multiple load balancers at the same time with policies that are configured centrally, but not have to do them manually. And when you make a policy change, that policy is then distributed and enforced by many logical network elements. So, good question here. So, one question we often get is NSX going to take away a network engineer's job anytime soon? Hunter, could you address that question that we often hear, that we've heard?
Yeah, absolutely, Scott. And that's a very, very common question that we get. People, especially the network engineers, see network virtualization and feel like this is somehow going to be replacing what they do. And I really just can't stress enough that is in no way the case. Essentially what NSX is going to be able to do is really allow the network engineers to focus more on their strategic initiative rather than just trying to focus on more of a day-to-day keeping the data center going. It's going to give them much more granular control of their networks through virtualization. And they're still the ones that know the network, they've built the network, they know how everything works. NSX is just going to empower them to be able to do a lot of their network changes in software. And again, allow them to focus on, more strategic things that they're trying to accomplish inside the data center rather than the menial tasks of just day-to-day operations.
Mm-hmm. Yeah, what that network engineer knows is still relevant. They still, their knowledge of spanning tree and routing and forwarding and good physical network design, still very relevant and important. A DevOps engineer, a developer, wouldn't have that information, would need to partner up with that person to figure out how to automate, what would be the right types of commands or RESTful API configurations to change on network elements. One group can't do it without the other group. They need to collaborate and cooperate there along those lines. Yeah, thanks, Hunter. I have another question here. Would micro-segmentation replace the perimeter firewall? Would you want to address that?
Yeah, absolutely. That's, again, another question that we often get. The short answer is no. NSX is not designed to replace your north-south firewall. You're likely going to leverage the hardware throughput and the capacity at the edge of the data center for a very long time. The issue is that in order to provide full security for east-west traffic, you would still have to hairpin all of those packets out to some kind of physical firewall device, which just is really inefficient in terms of keeping the data center running at its maximum capacity. You know, with micro-segmentation, we're going to distribute that firewall into software, and that'll essentially secure the inside of your data center, decreasing the attack plane that exists currently, as well as allow your perimeter to focus more on its job of guarding the perimeter of your data center. But no, NSX is not designed to replace the north-south firewall.
VMware doesn't replace the firewall, it accentuates it, it creates that orbital security model where you've got multiple, you've got diversity of defense and defense in depth, so you have a variety of components. VMware NSX can't solve malware, on desktops. You need another, security, system there. You may need intrusion prevention systems. You may need other kind of data loss prevention. There are other functions of security that are required to make a whole security defensive strategy. This is just another tool in the tool bag, but it's very easy to create firewall policies that are distributed and support many applications and services and servers in an easy way. We've got another question here. When using a Palo Alto or a Checkpoint firewall, virtual firewall on NSX, is the security administrator in two different management panes, or do they come together on one NSX management console? So I guess the question is, can from one management interface of VMware NSX I control Palo Alto and Checkpoint policies, or do I still need to go into the Palo Alto management console or the Checkpoint management console? Can you address that, Hunter?
Yeah, absolutely. So NSX is actually going to give you sort of a, utilizing our NSX controller, you'll have a control console or an NSX manager, which should allow for the automation and movement of packets to the third-party security vendor VMs inside of the data center. Now, from a perspective of can you control those virtual machines through NSX Manager, I believe the answer is yes. That's something that I would need to do a little bit more research on to give you a 100% clear answer. But I believe that, yes, you are able to control the VMs through the NSX Manager for those third-party security vendors.
Okay. Yeah, cool. I got another question here. So, yeah, if anybody has questions, just put them into the Q&A or the chat panel, and we'll get to them. Here's another question. How does global networking state awareness in a software-defined networking system, how is that implemented through NSX? So how does the application-specific network requirements get translated to policies that then get, controlled through NSX, defined in NSX, and then implemented on the, virtual network hypervisor there? So, would you mind answering that, Hunter?
Yeah, so I understand. So I understand the question correctly. Is this basically how does the virtual networks get distributed out with the policies that have been created throughout the data center?
Mm-hmm. Yeah, and then state awareness. So how, like if we see a connection made from a client to a web app server, how is that maintained? Maybe as that virtual system may move, or how is the state also of the environment maintained?
Okay, so everything is going to be controlled through NSX Manager, and the way that services are distributed and policies are enforced and we're able to track sort of the movement of packets throughout the data center, that's actually going to be done with the NSX cluster controller, which is essentially a virtual machine that we'll put on 1, 3, or 5 servers. We tend to like to go with the odd numbers for full redundancy. And essentially, that's where all of the network virtualization, the micro-segmentation, that's where everything is configured. And then those cluster controllers actually push out the policies, the virtual network, essentially everything that you configured inside of NSX Manager will be pushed out to all the hypervisors, to all the servers throughout the data center or multiple data centers. And again, that's all done by the 3 cluster controllers that are installed when a customer purchases NSX. Does that kind of answer the question?
I think it answers the question that came in over chat. Yeah, so I think another question we often get is, well, then where is this SDN controller in an NSX architecture? Where does it live? You know, it's really a piece of software, isn't it, Hunter?
Yeah, exactly. Most of our customers today, NSX Manager is just another plug-in to their vSphere client. So it's just, like you said, it's just a piece of software that can be managed through a vSphere client or independently of that.
Yeah, but because that NSX Manager is sharing information with vSphere, with vCenter, it understands the environment, and when you have multiple data centers with multiple vCenters, those policies are shared as well and synchronized, and that's what helps with that disaster recovery use case, right?
Exactly, yes.
Yeah. Okay. Well, I don't see any other questions coming across. If anybody has any questions, you can put them in the chat or the Q&A panel. If we don't have any more questions, then I want to make people aware that, you know, we're recording the session today, so you can watch a replay of it. You'll be able to forward this replay to your colleagues who might not have been able to join us today. We'll give you the slides that we presented today, so you can have them for your reference. And then VMware is also providing us 2 dummies books. Not to say that anyone here is a dummy. I have a dummy on occasion. I have my moments. But 2 really valuable books here that kind of go into a little bit more depth than what we did today on network virtualization use case and how network virtualization is supported in a VMware software-defined data center. And then a little bit more detail about micro-segmentation use case that we talked about. And 2 valuable books. And you may think, oh, these are really tiny little books, but I have the micro-segmentation book here, and it's like, it's quite extensive. It's, you know, 60-some pages, and it's a good read. So I definitely enjoyed reading both of these dummies books. And then also, even though we're concluding the session here, this doesn't have to conclude our interaction with you. So please feel free to reach out to myself or Hunter. Here's our contact information. If you have any further questions that we can answer for you, or you want to see a demonstration or see how this really works in a demo environment, we can get you the data you need, get you the information you need, and show you how this would work for your organization. I don't see any more questions, so I think we're close to concluding. Hunter, did you have any parting thoughts before we end the session?
You know, Scott, not really. You know, just to reemphasize what you said, if anyone has any questions or would like further follow-up, you know, please don't hesitate to reach out, give me a phone call, shoot me an email, and I'll be happy to get any other questions answered, and we can just kind of go from there.
Okay, excellent. Yeah, thank you for your insight, Hunter. I appreciate your time today. This was fun to share this information with folks. So thank you so much, everyone, and we look forward to seeing you on a future GTRI and VMware web seminar. Thank you, everybody. Bye.